Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a summary of the whole topic of compound interest. Now, this will be mostly for higher tier students as we are going to include some harder compound interest questions and compounding for decreasing values, or what we might otherwise call depreciation. If you would like to look at any of these videos in a little bit more detail or see more examples, then I will link the individual full videos down below as well. If you are foundation tier, feel free to check out the first two full videos on simple interest and compound interest anyway. Simple interest means whatever percentage of the money I put in, if I work that out in actual pounds, that amount of money in pounds is what I will get every single year for however many years I keep the money in the account. So the money that you earn as interest every year doesn't change. It's the same amount every single year. So let's actually put it in terms of this question because it needs a bit of context to understand it properly. So Hannah invests £1,000 in an account paying simple interest at a rate of 3% per annum. Two things to note about this sentence. One, they have to tell you which type of interest it is, because as we said, there is also compound interest and they are different. So they will tell you which type. The other thing is per annum. You just need to know that means per year. Okay, most of the time it is yearly. So every year she's going to earn 3% of £1,000. 3% of 1,000 every year. However many years she leaves it in there, that's what she'll earn. The question is, what is the value of her account after 2 years? Okay, so what we need to do is first go, right, I need to work out how much interest in terms of money, in terms of pounds, does she earn every year, so each year for 1 year. So that literally just means I need to do what is 3% of £1,000. So you type it in and go, what is 3% of 1,000? Well, that should give you £30. Now, as I said, that is interest per year, or per annum in this sense, per year. So every year, simple interest in this context, in this particular question, Hannah will earn £30 for year 1, £30 for year 2, £30 for year 3, right? Every year it's still £30 that she gets. Now it says we want to know for 2 years. So obviously I just then need to do what is 2 times 30. That would be £60. So that's her total interest across the 2 years. The other thing you then have to be really paying attention to is the question. Sometimes they ask how much interest is earned, in that case 60. Sometimes, like this one, they say what is the value of her account. That means how much money is still in her account now. Now obviously the £60 is there, right? The bank pays it into your account, but her £1,000 is still there. If she had taken her £1,000 out, she wouldn't be earning the interest, would she? There'd be no money to earn interest on. So we then have to do, just to find the value, is obviously her initial 1,000 that she had already put in the account, plus all the interest she's earned, which is £1,060. Okay, so in this case, the answer is 1,060. Sometimes the answer might just be the £60 interest. You have to check question well. So let's jump right into it. This is the formula for compound interest. I've obviously written it in my own way. I've written the initial amount. We then times it by 1 plus the interest rate over 100. So basically what this means here is just like the decimal version of the percentage, right? Because you know how percentages, when we use a calculator, we actually have to put them into a decimal format. So you don't necessarily have to use this fraction as long as you're happy with literally converting any percentage into a decimal. Just do 1 plus that percentage, okay, as a decimal. Then this bit here, just the bit here with the 1 plus the percentage, is to the power of the amount of time. Most of the time this is in terms of years. So as you can see, I will have the formula on each question, okay, so don't worry about that. Now, saying that this is the compound interest formula, I just want to make it clear, this is the formula that will give you what we call the value of the account at the end of, whatever the amount of years it is. It won't tell you what interest has been added on its own. It will give you the value of the account. So that means whatever they've first invested plus all the interest added. So in this context, Jane invests £3,000 into an account paying compound interest at a rate of 2% per annum. Okay, what is the value of her account after 4 years? So what we're looking for, if you look at this formula, there's 3 bits that are missing, aren't there? The initial amount, the percentage interest rate, and the time. So all you really need to do in terms of this question and the way that it's worded is pick out those 3 things, okay, and just put it into the formula, put the formula in your calculator, because this will be a calculator question, and then write down the answer. So if we were to match it up, for example, we've got the initial amount, which in this case is the amount they're going to invest. So we're starting with £3,000. We're going to have the rate or percentage interest, whatever you want to call it, which is here. And then we're going to have the time, which is this one, 4 years. So all I need to do in this case is write down, obviously I know you're going to put it in your calculator, but also write it down so you get the marks for the working. 3,000 times by, now if I'm to copy this exact formula, it'd be 1 plus 2 over 100, because that converts it to a decimal, and then to the power of 4. Now you can see again, the power of 4 is only for this bit here, it's not the whole thing to the power of 4. You can do either of these, it's whichever you're comfortable with. Do you prefer to just memorize the formula? Are you someone that works with percentages as fractions? Are you someone who works with percentages as decimals? It's very personal, but these are the same thing. So let's grab our calculator. I'm just going to type it in. I'll type it in the way that I've got the top one because I know that's how my formula is. So 3,000 times by, open the bracket, 1 plus fraction, 2 over 100, close the bracket, and then to the power. You see this, if you're looking for powers that aren't just squared, it's the one here where we've got x to the power and then like a box basically. So power of 4 and then press equals. You just need to write down this number. Now it is to multiple decimal places and you're probably thinking, well, it doesn't tell me how many decimal places to round it to. It doesn't technically matter. I personally just like to stick to doing 2 decimal places because it's money and money has 2 decimal places. So that would be £3,247.30. That would round to 30p, wouldn't it? Because of the 6. So £3,247.30. Now the reason why I said earlier that's the value of the account is because clearly, I mean, if you were to earn that much interest, that would be insane, that would be really good, but it's unlikely, okay? This is what's in Jane's account after 3 years. Obviously, still, the 3,000 is still there. If Jane takes the 3,000 out of her account, she can't earn interest on it, right? So obviously that's still there. And then anything that's beyond £3,000 is obviously then the interest. So that's why you have to be really careful. Double check your question. What have they asked for? In this case, yeah, they've asked for the value of the account. So this is your answer. 3,247.30 is your answer. Okay, so you can see here we've got exactly the same question. Jane, we've got £3,000, we've got 2% interest, we've got 4 years. However, the question now says, how much interest does she earn? So in this case, it's kind of an extra step. You have to use this formula to give you the value of the account. So obviously I know we already did that. Okay, so that was the value. I've just copied that from the previous page. So that's the value of her account. To find the interest though, you kind of have to do an extra step and you have to basically take this and just subtract the initial amount. Okay. So we're going to do 3,247. I mean, you can probably see the answer from here, but you know, just for the sake of getting the working out marks, write it down. Minus 3,000, which was our initial amount. Obviously, that's going to leave you with £247.30. That is the interest across all 4 years, all added together. That's what Jane earned in terms of interest. So just be really careful. Have they asked for the value of the account? In which case, just use the formula. Have they asked for the interest? Okay, step 1, use the formula. Step 2, work out the difference to get the interest. Okay, as I said, we're going to get some that are a little bit harder. You can see here we've got an example where, well, it's not necessarily harder, it's just a bit longer really, and you can get a few more marks for it. The reason being is you can see we've got 2 people, 2 scenarios. Okay, so it's going to take us just a bit longer. We're basically going to do the same process twice. So we've got here, Allie invests £2,200 in an easy access account. You can see here, easy access account. So I'm going to write down Allie's name just so we can make sure we don't get them mixed up. Callum invests £1,800 in a regular savings account. So Callum is over here. Who will earn more interest after 3 years? So, okay, first of all, we know we're looking for the interest. Now we're going to be applying this formula, but to the 2 different situations. So I'm just going to put a line down the middle so I can focus on them both individually. So you can see we've got 2 different initial investments, obviously for the 2 different people. We've also got 2 different rates. Now double check that they're both compound interest, okay? In this question they are both compound interest, but sometimes they might mix simple and compound interest together, so just be really careful about that. And they do have the same amount of time though, they're both for 3 years. So let's work out Allie first. We've got her initial investment, her initial amount is 2,200 times by, open the bracket, 1 plus her interest rate is 1.5 over 100 and then to the power of 3 years. So we get our calculator. 2,200 times by 1 plus 1.5 over 100 to the power of 3 equals 2,349 to 2 decimal places. Okay, now as we said, it is asking for the interest, and because they both have a different starting amount, initial amount, we can't really just see whose answer is bigger, right? Because they've started at different places. So I am going to subtract 2,200 from this to get my interest. So 2,349 is the value of Allie's account after 3 years. Subtract her initial amount, the initial value, and that should leave me with just £100, 49 pence. So that's the actual interest. So we've done Allie, now we just need to do Callum. Now we're going to do exactly the same thing, but obviously remember, he's got different numbers. So his initial amount is 1,800 times by 1 plus his percentage is 2, so 2 over 100, and still for 3 years. So we bring the calculator back, we type in Callum's version. We get £1,910.17. So £1,910.17. Okay, again we want to compare for the interest, so I'm going to take the value of his account after 3 years, which is the 1,900 number, minus the initial amount, which was 1,800, £110.17. Okay, now this is not the last bit, right? Because, yeah, okay, we've worked out the interest for both. However, they've said who will earn more interest. So they actually want us to write a conclusion. And I don't mean like a sentence, I just mean clearly indicate is it Allie or Callum, basically. So I'm going to put these little 3 dots, which means therefore, and obviously who has the more interest? Well, £100 versus 110. Okay, obviously that's going to be Callum. So just make it really clear who your decision is, okay? Otherwise, that's it. It wasn't much harder than the ones we've already done. We just had to do the same process twice. Sasha invests £4,000 into an account paying compound interest at a rate of R% per annum. The value of his account after 3 years is £4,060.30. Work out the value of R to 1 decimal place. Okay, so basically work out the interest rate. We're going to have to go backwards now. So you can see, of our formula, we've been given the initial amount, we've been given the time, and this is effectively the answer, isn't it? So I'm going to set up my equation with all of these pieces. So my initial amount is 4,000 times by 1 plus, now I don't know what the percentage is, so I'm going to use the letter R again, over 100, to the power of 3 years, and then I can put that as equal to £4,060.30. So you can see I've created an equation, and the only letter that I don't have is R. So all I now need to do, I can almost forget about compound interest at this point. I've used compound interest to know how to set up an equation, but now it's just basically algebra in terms of I need to solve this equation. I need to rearrange it to get R as the subject, and then obviously that would have solved it. So the first thing I'm going to do to rearrange it is I'm going to divide by this initial amount, okay? Obviously all of these are likely to be calculator questions, so divide £4,060.30 divided by 4,000, so we get all of this. I would just copy it all down, to be honest, but in your calculator we can use the answer button so that we don't have to keep copying it out. So I'm obviously left on my left hand side with just this bracket with the power of 3. So I get 1 plus r over 100 cubed still, because I've cancelled out this 4,000, equals all of this decimal. Okay, the next thing I need to do is cube root. The opposite of cubing is cube rooting. So I need to cube root both sides of my equation so that I can open up those brackets. Obviously, again, I'm going to do it on my calculator. What I'm going to do is use the answer button. You see this one down here. It's just going to copy all of these decimals. So to get the cube root, you might have to press the shift. You can see here I've got square root. Just above it is the cube root symbol. So I put shift and then the square root gives me a cube root. You see there's a 3 there. Put the answer button and then this is what I get. So on the left hand side, obviously it opens up this brackets here. Basically I still have 1 plus r over 100. And then on the right hand side, I'm going to write this down. As you can see though, it is basically 0.004999999 and so on. So I'm probably just going to round that at this point, okay? So I'm going to write it as 1.005, okay? Because that's effectively what it is, isn't it? Okay, now it's pretty straightforward. I'm obviously just going to subtract 1 and then times by 100. I get r over 100 is equal to 0.005, and then I will obviously have to times by 100. I'm just going to put it over here, so that gives me r is equal to, and if we times this by 100 we get 0.5, and that's now in percentage format. So it says leave it to 1 decimal place. I already rounded it over here, but effectively that's what you would get. 0.5% was the rate of interest. So that is your answer. So again, this is quite a common question. You might have to work backwards to find out the original interest rate, for example. just set up the equation and then solve it as if it were a normal rearranging question. Okay, this is our last question. It's similar to some of the ones you would have seen in the first video where we have two options, we have to investigate both and then give our answer or conclusion. But this one is technically harder because, as you can see, Bank 2 has this split interest rate as we saw in the first question. Okay, so I've just drawn a line down the middle so I can deal with both scenarios separately. So let's see, Amy wants to invest £4,000 for 6 years. Which account would offer her more interest? Okay, well, we're going to use our formula for both of them. The first version is easier, so we've got 2% compound interest each year. So our initial amount is obviously 4,000 times by 1 plus 2% over 100, and then all of that to the power of 6. Okay, so we just put that in the calculator, which as you can see gives us £4,504.65 if I round it to 2 decimal places. Okay, now it does say which bank gives her more interest, so you could subtract the 4,000 if you want to isolate purely the interest. But technically, because we're starting off with the same amount, the initial amount is the same for both banks, 4,000 or 4,000, the bank that gives more interest will be the bank that gives you a higher value anyway. So you don't really need to work out the interest if you don't want to, but I'll just do it for the sake of it. So therefore, the interest would be, as you can see if I subtract it, you can see it's obviously just £504.65 for that one. Okay, the second one we have to do our split working. So Bank 2 offers 3% compound interest for 2 years, and then 1.2% compound interest each year after. So it's for 6 years. So obviously we're going to get 2 years at 3%, and then the other 4 years will be at 1.2%. So I'm going to start off with the same formula, and I'm going to do 3% for 2 years. So my initial amount is obviously 4,000 times by 1 plus 3 over 100 to the power of 2. Put that in my calculator, which gives me 4,243.60. And then I need to work out the other 4 years. So my initial amount is now going to be that same value. The 4,243.60 is the new initial amount that I need to use. And obviously my interest rate has changed to 1.2%. And then for 4 years, which gives me £4,450.99 if I do it to 2 decimal places. So again, my interest, I just have to subtract the initial £4,000 to get just the interest, which would be £450.99. Okay, so that's the working, but it does say which account would offer her more interest, so you have to do a conclusion. So therefore, Bank 1 would be your answer. That would give her more interest. So I've put the formula here. It looks basically the same as the compound interest formula. The only thing that's now different is the symbol, because interest is increasing. When we've got compound interest, we're increasing the amount of money we have. When we've got depreciation or compounding when we're in a decreasing scenario, obviously we need to decrease the answer, so it's going to be subtract instead of the add. Otherwise, all the numbers are pretty much the same. So I will have this formula on each of the slides as well. Feel free to note it down or just add a little minus onto your compound interest formula as well. And let's see how it works. So they don't tend to mention anything about compounding. So it's not as obvious as the compound interest questions are, because obviously those ones say compound interest per year and so on. This one you just kind of have to figure it out and pick up on the clues. So for example, normally it will either be some kind of asset. So what we mean by an asset is something that you can own. So for example, like a car or a boat, could be even a house maybe. I guess like an object really that would lose value over time. So the more you use a car, the less it's going to be worth, right? Obviously. Or the other scenario that you might see is something about a leak or the rate at which water comes out of a pool or out of a water tank or something like that. So again, it's still decreasing, and the point is we have some kind of rate, some kind of percentage per year, month, hour, day, whatever it is. So here we've got a car costs £15,000 when new. The value of the car decreases at a rate of 12% per year. What is the value of the car after 8 years? So if you have a look at this carefully, hopefully you can kind of pick out that we've still got those 3 pieces of information that we look for when we go for compound interest questions. Because we've got an initial amount, so a starting amount, or a starting value in this case, a percentage rate, and we've got a time frame. Only the thing you've got to be aware of is it says obviously decreases, right? So that's where we've got the minus rather than the plus. So in this case, if I know, oh yeah, this is the same as like compounding, I can use the formula. So I've got my initial amount as 15,000 times by 1 minus, in this case, the percentage over 100, or just convert it into a decimal yourself, and then to the power of the time. In this case, because it's 12% per year, for 8 years, I can put 8. Then I would just put this into the calculator. Okay, and it says what is the value of the car after 8 years, so you just write down this new value, which is £5,394, and I'd probably round it to 2 decimal places because it's money, 52. And that would be your answer. It's literally as simple as that. They don't want you to go and work out 12% every single year, okay? Obviously that would take way too long. The 1 minus here, because we obviously, when we use percentages on a calculator, we have to have them as decimals, don't we? So what we mean by this is the 1 is the same as 100%. So obviously 100% was the original value of the car, the initial amount, minus 12 over 100, that's just obviously 12%. So what we're actually using is 88%, isn't it? And obviously 88% as a decimal is 0.88. So you could put it as 0.88 just automatically, and then obviously to the power of 8 years if you want, or just use the formula as it is. But that's what we mean by why have we got this 1, why have we got 12 over 100? Well, we're just converting the 12% into a decimal and then subtracting it from 100%. Okay, this is the other type of depreciation, well, decreasing value, I guess, or decreasing capacity question you might get with compounding. So in this case, we've got a swimming pool. So a swimming pool holds 60,000 litres of water when full. The pool is drained at a rate of 9% per hour. How many hours would it take for the pool to empty halfway? So because it says halfway, we first need to go, well, what's half of 60,000? That would be 30,000 litres. So what we're looking for is, at what point do we get to something that's just below 30,000 litres as our answer? So I'm going to set up the formula. Obviously, we're trying to find out the number of hours in this case. And as I said in the previous question, because it says 9% per hour and then it asks for how many hours, obviously the time is in terms of hours. Because they match, it doesn't matter. You don't have to worry about thinking about years or whatever else. They're already both the same units, so that's fine. So we set up our equation, we've got 60,000. In this case, the initial amount's actually not even in pounds, is it? It's in litres. Times 1 minus, now we know it's 9%, so 9 over 100. And we don't know what the time is. So I'm just going to put T here. And we're basically trying to get to the point where we type this in and it's less than the 30,000, isn't it? So it probably won't be exactly 30,000, but at what point would we get maybe like 29,000 or something, 28,000 the first time that we do that? So this one is kind of trial and error. We're just going to chuck in this formula to our calculator and then just choose a load of numbers for the time. So what I mean by that is type in this equation. Okay, so you can see I've left the power box open. I'm just going to test out a few. So maybe if I do to the power of 3, what does that give me? Okay, that gives me 45,000 still, so we're not close to halfway. I'm just going to use my back button so I don't have to delete the whole thing. Maybe I'll put 5. Okay, 37,000, we're getting closer. Not quite yet though. Let's try 6. 6 is 34. Okay, let's try 7. 7 gives us 31,000, so we know that probably the next one is going to go below, isn't it? What I would do to write down at least some working out is maybe write down the number that gives you just above halfway and then the number that gives you just below. So I'm going to write all of this down with the power of 7. Okay, I'm not too fussy about the decimals, and then I'm going to try to the power of 8. Okay, can you see how now this one's gone below 30,000? It was the first year. We're not going to do half years. It was the first year in which we went below the 30,000, so that's the first year where we have hit the halfway point. So I'll write down this one as well with the 8 years. Okay, so you can see I've written down a bit of working out, so you can see the one just before it goes halfway and the one just after, and then obviously for my conclusion, therefore it takes 8 hours. Sorry if I was saying years, I think I probably said years at some point. 8 hours, okay, so that would be your answer. So in this case, when you're trying to find out the time, just try out a few numbers until you get close and then write down the 2 that are around that point that they were looking for. I have seen this question quite commonly with the context of a water tank, and it says the water tank is leaking at a rate of whatever % per hour. Same kind of thing, isn't it? That's everything you need to know about compound interest, so thanks for watching this video. Make sure you leave any questions or comments you have down below, and like and subscribe.